So today we continue the previous lecture. Previous class we discussed ending class force between the multiple charges. Okay. So here we see that Q1 charge express force due to Q2 and Q3, and Q2 and Q3 are both are positive charges. If anyone turns into negative charge, let me say that if Q2 is the negative charge, so what is the total force on Q1 due to Q2 and Q3? So copy the diagram first. Okay, here we now change that Q2 um, so Q2 is a negative charge. Okay, so if Q2 with a negative charge, so I think that may be a change. Okay, because if Q2 with a negative charge, so force F12 actually in that direction. So F12 in that direction. Okay. So if F12 in that direction and Q3 is a positive charge, Q1 is the positive charge. Okay, so how do I calculate a total force? Actually F1. Now from vector algebra, we draw a parallel of F1. Okay, from starting here to here, that is a F1, and know that that is a vector, and similar that is also a vector. If both direction are same and both are same magnitude, so these two vectors are equal vector. So F1 is also equal to this vector. Okay, in that direction. And so now we apply the vector triangle law. We say that the all clockwise direction is the positive and anti-clockwise is the negative. So we see that at F12 clockwise, that is F12 plus F1 and minus F13, that is equal to 0. Okay, but here is the important factor is that at this F1 that is equal to F13 minus F12. If I put the value, actually F13 means some constant K, Q1, Q3, that's only magnitude. Okay, that's only magnitude by R13 square, R13 cap plus, sorry, that minus some constant K, Q1, Q2. Now important thing is that R12 square is okay, but here is not the direction of R12, that is the opposite of R12. Actually, previous the R12, see that when that is a displacement vector, when force F12 from left to right, but here in that case force is right to left, so that is a minus of R12. So minus R12 cap. Now we minus K Q1 Q3 by R13 square, R13 cap, minus plus K Q1 Q2 by R12 square and R12 cap. So R12 or R21 will be the same. Okay, so R12 or Q1 magnitude actually is same, because A vector dot A vector, that is scalar product. Dot product means a scalar product. So A dot A, we know that magnitude of A, some against the magnitude of A, and cos theta. Theta is the angle between A and A. So you know the angle that is 0 degree. A and A between angle is 0 degree. So cos 0, you know the 1, that is A square. So A square is a scalar. So scalar means R1 to R2 be the same. Dot product, same vector dot product. Okay, so that is we get. And now similar, yes, you solve that. That is equal to K and Q1 common, and we get a Q3 by, if I first put Q2, okay, actually Q2 by R12 square, R12 cap, plus Q3 by R13 square, R13 cap. If you more than the charges of the Q1, summation I equal to 2 to n particles, Qi by R1I square, R1I cap. Okay, that's the total. Easily we can solve this if one charge is negative. Actually, that's a vector algebra. Okay, that's nothing to worry about, because if you know the vector algebra, that's just very easy, because that is the f1 and f1. This is a parallel. If you know the basic vector algebra, then you can solve any type of numerical. Okay, or any type of diagram. If someone says the q3 is a negative and q2 is a positive, how do you can solve? So next, there's a diagram here. If say that Q3 is the negative charge, what will happen? If Q3 be the negative charge, uh, minus Q2. So if all three now be the change, that is F13. Okay, in that direction. So similarly, you see that now we can draw the same condition. Okay, parallel to F1. So parallel to F1 means like this. Okay, starting here to there. That is a parallel of F1. Okay. So now we apply the vector triangle law. Clockwise is positive and anti-clockwise is negative. And if you choose the clockwise is negative, anti-clockwise is positive, both are true. Okay. So if I choose the clockwise is positive, so that is a F12 is a positive, plus sorry, minus F1, because F1 is a negative anti-clockwise, and F13 also negative anti-clockwise, that is equal to 0. So we finally get F12 minus F13, that is equal to F1. F12 means K Q1 Q2 by R12 square R12 cap, K Q1 Q3 by R13 square. Now what is the R13 cap? R13 cap actually in that direction. Okay. Now the force direction change, 180 opposite. So that is the minus of R13. So minus of R13 cap. So similar. So cancel these two. Q1 Q2 by R12 square 12 cap. plus k q1 q3 by r13 square and r13 cap, that is the f1 of total force. So finally you can solve this, that is f1 equal to k q summation I equal to 2 to n, so qi by r1 I square r1 I cap. Let's jump this from here. Actually, we solved maximum various type of, okay. Previously you can solve this, so that's why we skip that middle stage. Clear? Okay. Now we can calculate a mathematics. Okay, so basic mathematics of NCERT maths. NCERT maths. So that's a given. Okay. So if I choose a triangle, for example, a triangle. After. Okay. So to given a triangle A, B, C point, there is a three chart, small q and small q. Okay. Both are positive. Okay. So that is equilateral triangle. That is these three sides are equal. Now calculate the mass center here. Okay. There is a force on the charge q. Okay, what is the centroid point? Okay, that centered point is capital Q. What is the force experienced capital Q due to all three charges? Force capital Q due to all three of charges. Q, and Q are 3 points. Okay, very easy question. How to solve this question? That's the initiative. First, we see that if that is a positive charge, that is also positive charge. So Q experience force due to B Q charge. All three charges are same. Okay. So the Q charge, capital Q charge experience force due to charge Q at point B. So force that both are is positive. So force is that direction. Okay. That is F and O. O, that is F of OB. Okay. Outward direction. Similar the case at plus Q to plus O. So both are positive. So Q plus Q experiences a charge due to A point charge. Both opposite. So F of OA. Similarly here that at C. Okay, so similar that is a Q experiences a force due to charge, small charge plus Q at point C. That is F of OC. So very easy. So finally added the all. The total that is equal to F of OA. Just superposition theorem. F of OB plus F of OC. Okay. So OA means the OA means capital Q small q by OA square. Okay, so AO direction, actually AO unit vector or direction. Okay, KOB. OB means we know that capital Q times small q, both charges by the distance OB square, and direction is BO cap. Very important in that direction, displacement vector. Similarly, the OC K constant. OC means this KQ times capital Q times small q by OC square. Now we can finally common the change capital Q times small q by OA square, OB square, OC square are the same. Okay, actually because they are the equilateral triangle, the all sides are equal. Okay, that's why the OA equal to OB equal to OC. Okay, so OA equal to OB equal to OC. That's why the OA square say that common. Okay, so find so that is equal to AO cap plus BO cap plus CO cap. Okay, so now important thing is that is both are same. Okay, so these things are common. So finally now we check to calculate the AO cap plus BO cap plus CO cap. Okay, now we can apply the vector triangle law here. Okay, so actually the OC algebraic sum of all points. Okay, here. So if I choose here the diagram, that is a f of OB, that is a f of OA, and that is equal to f of OC. So the unit vector representation, that is OB vector, that is O OB vector. Sorry. That's not OB vector. That is BO vector. Actually, in that direction. Okay. So that is BO vector unit vector. That is CO unit vector, and here that is O AO unit vector. AO unit vector. Okay. Now we see that if I consider that is here. Um, that is CO, but I say that if say the CO vector, we increase the CO vector. Okay, that actually is CO vector, and if I apply BO vector here, vector CO, BO or BO parallel, this is the extended of OC vector, CO unit vector, that is AO. Now we added, okay, now we added clockwise added, okay, all this. Okay, so I think the CO is anti-clockwise, CO minus BO also anti-clockwise, that is a BO minus AO also the anti-clockwise, minus AO unit vector, that is all 0. So finally say that the CO unit vector, BO unit vector plus AO unit vector all 0. So okay, that's the 0. So K times capital Q times small q by OA square, that is times 0. So get so force at that center here, that is 0 Newton. Actually the force is or you can also say that that is the force equal to 0 Coulomb square, also the meter to the minus 2. Because you know that the ascent of the force is proportional to K Q1 Q2 by R square. So here the Coulomb square meter to the minus 2. That's the answer. Okay, so we can solve this type of numerical both JEE and NEET. Okay. So next topic we discuss an important topic is called a electric field, and a very important topic is electric field. So electric field. So electric field is a vector field. Electric field is a vector field. Okay. So electric field is a know that is a vector field. As well like that a charge field, like a temperature of the room. This also a field is called a scalar field. The pressure of a bottle, okay, or a tank, water tank in water pool. These are called a pressure field. Okay, these are all called a scalar field. But here we discuss a vector field or an electric field. Okay. So the important thing is how do we calculate what is the electric field? So you know that is a charged body is considered a glass tube. These are all positive charges. Okay, all positive charges. Now we bring a test charge. Okay, this is a source charge body. Now bring a test charge. Suppose a plus q at that point, and the separation between these two is r. So these test charge experience some force due to that, or that force in that direction, that is F outward direction, because both are positive charge. So that is the force. We know that is a capital Q charge, that is some constant K, capital Q, the test charge. Now consider the small q, the small q by separation square. Okay, that is a r cap unit vector, because force is the function of r, because very important, the function of r, force. Now if I divided by if of r force by test charge, so we can get a k capital Q times small q by r square times small q r cap. So cancel these two. So f of function r is a vector by the q, small q, and k times capital Q by r square, the source charge body, and r cap, that is the electric field E of r. So field means a boundary. Okay, actually say that the object area of that object when they can apply the force. Okay, that's the boundary of the object. That's called a electric field. Okay, at that point there is a q charge experience some force, but here you can place this q charge plus test charge experience a small force, but at certain point the q experiences zero force due to the q body. There's a boundary of that q charge body, the field, boundary of that field. So actually test charge experience some force at, okay, in any direction, not only in that direction, in any direction. If test charge experience some force due to source charge, that means the test charge placed on the field of capital Q, or source charge field. Okay, so field means a boundary. Okay, where they can act. That's the field. So where they can act. That's the field. If someone says, say that is my field, that's my ground, means that the boundary, the edges inside the boundary, that's the field of the superpower of the man. Okay, inside the field there is a superpower, but outside that field there is a no power, means zero power, means Someone say that this if you have a bird to meet at that point, okay, because that is my field. At here my field is you. Okay, field is with a q charge act as if q charge pushes the or express some electric field actually. Both are vector field and E and F both are in same direction. Okay, clear? So can define that if that a charge object on a single charge or charge bodies, okay, create a force in all directions. Create a force in all directions. Okay, and create an electric field in all directions. Now also create an electric field in all directions. Okay, that's very important. That's the final equation of the electric field. That is electric field E depending on R with the vector field that is A of R by test charge Q. Okay. Now, if I say that taking some example, I will say that is a charge um, uh, Q plus Q charge here. Okay, plus Q, that is a source charge at some distance, R distance. There is a plus test charge, a small test charge Q, and that Q experience some force. Okay, if both are in positive, they experience force in outward. Okay, that's test charge, and we know that the electric field that is q by r square and r cap direction, and the electric field is independent of test charge, is independent of test charge, okay. So that is the value, that is E equal to 1 over 4 pi epsilon naught permittivity of free space. We know that the value, and that is a capital Q source charge by R square and R cap, and that the electric field. Electric field is the abstract property set by the charge object. Actually, electric field is the abstract property set by the charge object. Set by the charge object. So SI unit of the electric field, you know that very easy. So SI unit is that is F by Q, also called Newton per Coulomb. Very easy answer. And you can also say that we know that F equal to K C square by meter square, and that's some C. So C cancel. So that is the unit is Coulomb per meter square. Okay, that's also the SI unit of the electric field. Okay, so today end the class here. Thank you.